Hello geometry students. This is the second part of the lesson on dilations. Remember, if the scale factor is larger than 1, then it is an enlargement. If the scale factor is smaller than 1, then it is a reduction. So we take a look at problem number 5, given triangle ABC, and I introduced a new symbol. That symbol I highlighted in yellow means similar. What similar means is it's the same shape, but is simply a reduction or an enlargement. So it says, what is the scale factor from triangle ABC, which I'm going to highlight in yellow, to triangle DEC, which I'm going to trace in green. So from the yellow to the green, we can see that this is an enlargement, which means the scale factor is larger than 1. So if I look at this particular problem, I know in the yellow triangle, point B is 0, 6. So that means this distance here, I'm going to highlight this in red, is 6. And in the green triangle, I have point E, and that distance is 22. So the sides of the little triangle, I'm going to draw this. The little triangle, this side is 6. And in the big triangle, the green triangle, that side is 22. So if I want the scale factor, I'm going to take the larger number, 22, and divide by 6. And using the TI-82, 22 divide by 6, I'm going to press math fraction. I get the scale factor is 11/3. So the scale factor here is 11 over 3. Now for clarity, you could have used the other dimensions. So if you look at the other dimensions here, AC is 12. So that's 12. I'll put that at the bottom. And all the way across is 44. So another way you could have done this problem is 44 over 12. And just to show you, 44 divided by 12, math fraction, you still get 11/3. So the scale factor here is 11/3. Let's take a look at problem number 7. In problem number 7, given triangle ABC is similar to triangle DEC with a scale factor of 3. So from the little triangle that I highlighted in yellow to the big triangle that I just highlighted in green, we know the scale factor is 3. What are the coordinates of point A and the coordinates of point E? If we look at this problem, we know B is 0, -9. So if I want to get to point E, I'm going to multiply by 3 because the triangle is getting bigger. So if I multiply 0 times 3, I get 0. If I multiply -9 times 3, I get -27. So E is 0, -27. In contrast, if I want point A, I'm going from the bigger triangle to the smaller triangle. So instead of multiplying by 3, since I'm going to the smaller triangle, I'm going to divide by 3. So -48 divided by 3 is -16, and 0 divided by -3 is 0. So point A is -16, 0. Let's apply that idea to problem number 6. Given triangle ABC is similar to triangle DEC with a scale factor of 4/13 from DEC, so DEC is the large triangle, so that's the large triangle, to the smaller triangle ABC, so it is a reduction. What are the coordinates of point A and E? So from point D to A, Notice the side length is getting smaller, so I'm going to take negative 39 and multiply by 4 over 13. And I'm going to get my calculator out here. Negative 39 times 4 divided by 13. I get negative 12. And so point A is going to be negative 12, 0, because when I multiply 0 times 4 13s, I still get 0. In contrast, from point B to point E, we're getting bigger. So when we talked about scale factor, the scale factor must be larger than 1. So for point E, I'm going to take the 12, and instead of multiplying by 4 over 13, which is smaller than 1, I'm going to take the reciprocal and multiply by 13 over 4. And doing that on my calculator, 12 times 13 divided by 4, I get 39. So point E is 0, 39. And that's just a coincidence that those numbers are the same. Let's take a look at our last example, problem number 8. In problem number 8, I want to dilate triangle ABC by a scale factor of 5/2. So what that means is I'm going to take every point and I'm going to multiply by 5/2. So using my calculator, if I say negative 2 times 5/2, I'm going to get negative 5. If I say 4 times 5/2, I'll get 10. So the new point A prime is going to be negative 5, 10. Now multiply point B by 5/2. So negative 1 times 5/2 is negative 2.5. And negative 5 times 5/2 is negative 12.5. So point B prime is equal to negative 2.5, negative 12.5. And then the last point, we're going to take 4 and multiply by 5/2, and negative 4 and multiply by 5/2, and you get 10 and negative 10. So C prime is 10, negative 10. And now I'm going to plot the points. Negative 5, 10. That's A prime. Point B, negative 2.5. And it's okay to have decimals. Negative 12.5. Looks like it's right there. I'll call that B prime. And then C is 10, negative 10. So there's C prime. And if I were to connect these points with a straight edge, and I don't have a straight edge, so feel free to draw this by freehand, that is the enlargement by a scale factor of 5/2. I hope you found this video helpful.